Hello everyone, this is the last class of the second week. So it's a lecture number 5 of this second week, and in this lecture we will only putting assignment of this. Some of the assignments are quite easy and already solved in the previous lectures 1, 2, 3, 4 of the second week. So you will go through it and you will find out that these assignments are just a revision for you. But some of these assignments are quite helpful to build your concepts based on the lectures we have given from lecture 1 to 4, right. So look at this assignment problem. So we have contained 7 assignments for you, and each assignments have a different based on the different lectures. So you have to remember the definition of a Cauchy sequence, then Cauchy convergence sequence, then the relationship between convergence and a boundedness sequence, convergence and a Cauchy sequence, and then you have a monotone sequences, the upper bound of a sequence or set, lower bound of a set, supremum of a set, and infimum of a set. You must know how to evaluate the supremum and infimum of a set by using the collections of the upper bounds and lower bounds and finding out the least upper bound and finding out the greatest lower bound. So these assignments will give you or boost up your own concepts of these lectures, right. So look at assignment number 1. Find least upper bound, supremum, and the greatest lower bound, that is infimum, of the following sequences. So first one is given an is equal to 1 and 0, 1 when n is even and 0 is n is odd. Let me give you, with each assignment I will solve one questions, not necessarily the first one, any one, and then I will left for you. So the first one, let me solve for you the first one. So an, so I can write this one n as a sequence as n is even and n is odd. So this is 0, this is 1, this is 0, this is 1, this is 0, this is 1, and so on, right. So here it is the first one, this is the second one, this is the third one, this is the fourth one, and so on, right. So odd is 0 and even is 1. Now what will be the supremum and the infimum? So look at for the supremum. Supremum is the least of all these upper bounds, right. What will be the upper bounds? Upper bounds is 1, 1.1, 1.5, 2, 3, 4, 5. Any number which is greater than 1 will be their upper bounds. So I have a collections of upper bounds. I have a collections of upper bounds and I will choose the least one. So what will be the least among these? This is the least of 1. So supremum is 1. So here supremum is 1. Look at the infimum as well. So let me collect all the lower bounds. So lower bounds is 0, minus 0.1, minus 0.2, minus 1, minus 3, minus 5, and so on. Any number which is less than 0, less than and equal to 0 is the lower bounds, So what will be the greatest lower bound? The greatest lower bound is 0 itself, and henceforth infimum, that is equal to greatest of all these lower bounds. All these lower bounds is nothing but, right. So this is quite easy. Already told you about cos n. Can you evaluate it? What will be the value of cos n? So look at the structure of this cos n, cos 1, cos 2, cos 3, and so on. So you will see that finding out supremum or lower and upper bound of this cos n will it's a very tedious job, isn't it? So I will left for you to do this, and once you will do it, you will find out that this will boost your or enhance your concepts in this greatest lower bound or least upper bound. Similarly, any other things which I will take up? This one or this one, you can see, right. So what will be the maximum value or the upper bound? So let's say n tends to infinity. What will be the value? 1 by 2, right? So this will be easy to do. Similarly, another assignment, and in that assignment I have put another questions for you, and this is the sequence where nth term is given minus 1 by power n plus 2. So look at these sequences. So this is the sequence minus 1 by power n plus 2. So I will expand this sequence minus n equal to 1. So this will minus 1, minus 1, minus 1 plus 2, minus 1 plus 2, minus 1 plus 2, right? So how much the value? This will become to minus 1. So this will come to 1. So the first term a1 is equal to 1, a2. What will be the a2? a2 is minus 1 cos squared plus 2 is equal to 1 plus 2 equal to 3. Now it is going to be repeat itself, right? a3 is again minus 1 by power 1 plus of 2 is equal to minus 1 plus 2 equal to 1. So the sequence become 1 3 1 3 1 3 and so on, right? So what will be the lower bounds? Lower bounds are 1, any number which are less than 1, so 1 by 2, 1 by 3, 0, minus 1, minus 2 and so on. These are the lower bounds. These are the lower bounds. What will be the greatest lower bound of among these? This is 1 is the greatest lower bound. So infimum is 1. And similarly, what is the supremum? Supremum is 3, right? So sometime it is easy to find out infimum and supremum by expanding itself the sequences. Look at a constant sequence. What do you think? What will be the lower bound and the upper bounds? So let me do this for you. So n equal to 5 is given here, n equal to 5. So if I write in a sequence way, I have 5, 5, 5, 5, 5, 5. So what will be the lower bounds? Any number which is less than 5 and equal to 5. And what will be the upper bounds? Any number which is greater than equal to 5. What will be the greatest of that lower bound? This is 5 itself. And what will be the least upper bound of this? This is 5. So the infimum and supremum both are is equal to the same constant number 5. Similarly, we can have n equal to 3 plus 1 by n. How to do this? 3 plus 1. 1 by n has the maximum and minimum as 0 and 1. So this series maximum has 3 plus 1 is equal to 4, and the series has the minimum is 3 plus 0 is equal to 3. That means the series may have the terms between 3 and 4. So what will be the lower bound and upper bounds? Lower bound and upper bounds are nothing but it is 3 and 4 respectively. Similarly, find whether the sequence is monotonically increasing, monotonically decreasing, or it is neither. That means it is neither increasing nor decreasing. That is also called non-monotonic. So this is quite easy to do this, and sometime you have to remember that monotony increasing or decreasing totally depends on the differences between its consecutive numbers. So you will choose arbitrarily small n, that is any terms of that sequence, and choose the next term, that is n plus 1 term, and find out the difference between these two terms. If difference is greater than 0, it will be a monotonic increasing sequence. If difference is less than 0, then it will be a monotonic decreasing sequence. So I will do the same thing. So if I have an plus 1 and minus an, all the time I will do the same thing, an plus 1 and an, not modulus. So now we have n by n power 10, and n power 10 become n plus 1 power 10 minus n power 10. So that means as you can see here, you will have some terms, you will have something n plus 1 power 10. You can write n power 10 into plus of 10 into of n power 9 and plus of 10 into 9 divided by 2 into n to the power 8 and 10 into 9 into 8 divided by 3 n to the power 7 and so on, right? And just subtract n10. So I have, so subtracting minus of n10, it will gives me this number, and these numbers, since n is already natural numbers, so that means n is already non-negative numbers, so these numbers are greater than 0 itself. So this will gives me greater than 0, a strictly greater than 0. That means this is monotonically increasing sequence, and not only this, but it is a strictly monotone increasing sequence. Similarly, look at this problem. This is a constant sequence, and it will ask that can you decide it is a monotone increasing or monotone decreasing sequence or neither. So let us suppose n plus 1 minus n, and both are the same. So 2025 minus 2025 is equal to 0. So it cannot be written as this is greater than or strictly greater than 0 or strictly less than 0, but it is equal to 0 itself. So we can see in a lame language that an plus 1 minus an is greater than or equal to 0 will give us a increasing sequence and decreasing sequence, but not a strictly decreasing or increasing, a strictly decreasing or increasing sequence, right? So this is the way to do this. What about the question number 4, where we have an equal to sin n? Do you have any idea? So let me give you how to solve it, right? So sin n, so I can find out an plus 1 first. So this is sine of n plus 1, and what will be the n? N is equal to sine of n, right? So n plus 1 minus of n is nothing but sine of n plus 1 minus of sine n. Now use sine of a minus of sine b formula. You can use that formula and you will reach to the conclusion, right? Or you can convert it in a half of cos of a into cos b and so on, and you will find out that it is less than or greater than whatever it is. You will find out very easily. So any problem consisting of trigonometrical terms, you will use the formula between the differences between the two trigonometrical terms, and you will find out easily that it is a monotone decreasing or increasing sequence. Similarly, assignment number 4 also consists of the same type of the problem, where we have cos n here, and you can do the same thing. N plus 1 minus of n is equal to cos of n plus 1 minus of cos of n. So this is cos of a minus cos b type of this. You can write the formula and you will reach at the conclusion that it is greater than 0 or less than 0. Since it is assignment, I am just left this one. Look at question number 4, an equal to, so write down first what it will saying, and you will find out that how I can reach at the conclusion that it is monotone increasing or decreasing or neither. So write down this. Firstly, I am going to write a1. a1 is equal to 1, a2 is equal to 4, a3 is equal to 9, and a4 is equal to 100, a5 is equal to 100, a6 is equal to, how much? a6 is equal to 100, and so on. Now you cannot reach at any conclusion. So since take this a2 minus a1, a2 minus a1 is equal to 4 minus 1 equal to 3, which is greater than 0, which is quite good. But a5 minus a4 is equal to 100 minus 100 is equal to 0. So it is not greater than 0, not less than 0, but equal to 0. So that's why such a sequence will not give you any conclusion, or you cannot conclude that this sequence is monotone increasing or decreasing. So in this case, we call it such a sequence as a non-monotonic sequence. Now the problem assignment 5 is based on the convergent or divergent of the sequences. and finding out its limit. So, find out limits is quite easy. I will solve the first one. You will solve any questions at all. Let me solve this the first one. So, limit n tends to infinity, n divided by n plus 2 can be written as by dividing the highest power. So, this is n divided by n divided by n divided by n divided by n plus of 2. So, this is cancel out and this will comes out limit n tends to infinity 1 divided by 1 plus 2, 1 by 2 pi by n. So, 2 by n is going to be 0. So, this will comes out to be 1, right. So, this is the limit, and is this convergent or divergent? Obviously, it is a converging sequence. Converges to where? Converges to 1. Similarly, 1 minus 1 by n square. So, find out the limit of this. 1 by n square is converging to 0, right here. So, therefore, limit n tends to infinity 1 minus of 1 n square, and this will comes out by using the algebra of the limit. So, this is 1 minus of limit 1 by n square. So, limit 1 is equal to 1. So, any constant here, and 1 by n square is 0. So, this is 1. So, finding out limits is 0. What about the cos n? It's a quite good questions, and I am leaving for you that how you will reach at the conclusion that is this a convergent sequence or diverging sequence. If it is a converging sequence, what will be the limit of that sequence, and if it is a diverging sequence, where it diverges, either it is going to be 0, I mean minus infinity or minus or plus infinity. You will conclude it by looking at the terms and so on. Similarly, an equal to tan inverse n. In the previous lectures, we have already done this. So, limit of n tends to infinity, tan inverse of n is nothing, but it is going to be pi by 2. We had already proved this one using the epsilon and their definition, cossequential differential. So, this is n by 2. What about natural logarithm n divided by n? Just explore with your own concepts, and let me know that it will be easy to you or not. Assignment 6. Determine whether the given sequence is convergent or divergent. If it is convergent, find its limit. So, look at the first problem. This problem is n itself. So, expand this sequences. So, an can be written as a sequence. I can written as 1, 2, 3, 4, 5, 6. So, where it converges, it is not converging, it is going to be diverging, and diverges where? Diverges at plus infinity. Similarly, look at this problem. This problem is quite easy to do this. So, this an is nothing but you can have this 3 minus of 1 by n. So, limiting of n tends to infinity, 3 minus n. So, limit of 3 minus n. So, use the limit of algebra, n tends to infinity 3 minus of limit 1 by n. So, any constant is the constant itself, and this will going to be 0. So, this is 3. So, this is easy to do this. What about 2 pi power n? We had already done it, right, in the previous slides. You will find out easy. Now, the last assignment we have here, determine whether the given sequence is convergent or divergent by using Cauchy's general principle of convergence. Do you remember the general principle of convergence? Cauchy's general principle of convergence. I am just writing for you. An plus p minus of an modulus is less than epsilon for every n is greater than m, and p is equal to 1, 2, 3, 4, 5 and so on. So, what you have to do? You have to first find out the difference between two terms. Firstly, determine what will be an plus p minus an and its absolute value. Once you determine, you will find out in terms of some epsilon or so on, and then you will determine here that for what m as a natural number, that is a function of epsilon, it holds. and once it holds, if there exists a natural number m which depends on epsilon, then you can use this Cauchy general principle and conclude that this sequence is converging sequence and this sequence is a Cauchy sequence as well. This is e power minus n, right. So, sin 1 by n, look at and give much more time to find out sin 1 by n. This is a very good question and you have to evaluate it by using your own concepts. Determine whether the given sequence is convergent or divergent using the same Cauchy general principle of convergence, in which we have put it in place of sin n cos 1 by n, 1 by factorial n, and this question. This is a good question for this. You can explore it and you will find out that this is going to be a converging sequences. So, the last assignment is based on the same thing, and you will find out 2 power 1 by n cos of n 3 minus 1 by n q and so on, and use the same principle n plus p minus of n modulus is whether epsilon, if it is, whether there exists a natural number m or not. If there exists m, then it will be hold and it will fulfill the Cauchy general principle of convergence. So, thank you, and I hope that this week we have learned Cauchy sequences and many more things. So, I believe that you will do the assignment itself and give some time on each of the problem, and then it will be boost your or enhance your concept. Thank you again.